So, hello, hi everyone. Welcome to this student brand. This is your Sivasa. Today topic is electric current. So, tomorrow is the exam. So, everyone focus, be serious, and prepare well. Revise all the chapters, revise all the topics. Okay. So, be confident, be strong. Okay, so think about only your concepts, think about only your preparation. So everything will be going good. Definitely, it went well. So it goes well. Okay, so you don't worry about the exam. So prepare, revise. Okay, so revise once again what you have learned till now. Okay, so prepare well. So revise, focus on preparation. That's enough. So definitely it goes good. So now I'm explaining the topic electric current. Electric current, electric, electric current. So electric current is nothing but the rate of flow of charge is called electric current. The rate of flow of charge is called electric current. I equal to Q by T. SI unit of electric current is ampere. SI unit of charge is coulomb. SI unit of time is second. 1 ampere is defined as 1 coulomb of charge flowing through unit cross section area per second. Okay, so 1 ampere is defined as 1 coulomb of charge flowing through unit cross section area per second, that is called electric current. So I equal to Q by T, I equal to Q by T. So SI unit of electric current is ampere, SI unit of electric current is ampere, SI unit of charge is coulomb, SI unit of charge is coulomb, and SI unit of time is second. SI unit of time is second. So 1 ampere is defined as 1 coulomb of charge flowing through unit cross section area per second. 1 ampere is defined as 1 coulomb of charge flowing through unit cross section area per second. Okay. So 1 ampere equal to 1 coulomb per 1 second. 1 ampere equal to 1 coulomb per 1 second. Understood? So here inside of the conductor, so there is one question related to this SI units. SI unit. So related to SI unit, one MCQs will come. Okay, so they will ask one MCQs regarding this one. And define SI unit of current, define electric current. So like this they will ask, okay. So you have to define those terms, and after that so they will ask about quantization of charge, related to quantization of charge and the values. Okay, so I already mentioned those values. You have to remember compulsory, those values you have to remember without any. Okay, so second thought. So here electrons are moving inside of the conductor. Electrons are moving inside of the conductor. There are many electrons are moving. We can't say only one electron is moving, only two electrons flows, only three electrons flows. We can't say current is flowing. There are many number of charges. So many charges are moving in the conductor. Then only we can say current is flowing. So that's why that is called quantization of charge. Q equal to plus or minus Ne. Q equal to plus or minus Ne. On one electron, so how much charge is present on one electron? 1.6 into 10 power minus 19. On one electron, you can say on one electron 1.6 into 10 power minus 19 coulomb. In 1 coulomb, 1 by 1.6 into 10 power minus 19. Then if you do it 1 by 1.6 into 10 power 19. So if you solve this one, you will get 0.625 in 1 coulomb. So you will get 0.625. So in 1 coulomb, in 1 coulomb, 0.625 into 10 power 18, 10 power 19 electrons. So because if you solve this one, you are getting this one. Okay, so after removing one zero, we can write 6.25 into 10 power 18 electron. 6.25 into 10 power 18 electrons. I hope it is very clear. So this is the answer. So very important. Make sure that you remember these points. So this point, that is on one electron how much charge is present, this one you have to remember. And in one coulomb how many electrons are present, 6.25 into 10 power 18 electrons. Understood or not? These 2 points you have to remember. Okay, 1 ampere equal to, so this are define. So define SI unit of electric current. They will ask about define SI unit of electric current. 1 ampere is defined as 1 coulomb of charge flowing through unit cross section area per second, that is called 1 ampere. So Q equal to plus or minus Ne. Q equal to plus or minus Ne. So on 1 electron 1.6 into 10 power minus 19 coulomb. In 1 coulomb 6.25 into 10 power 18 electrons are present. So that's enough. So next one is so we'll discuss about electrical elements. So whatever is there in the textbook, completely those elements you have to learn. And okay, so symbols, electrical element symbols, they will ask for okay, so definitely they will ask. So giving the symbol and they will ask what is the symbol represent. Okay, what is the symbol represent, they will ask. So here you can see here in the table, the tabular column. Okay, so electric current. So you can see here, okay, in the tabular column whatever it is there. So you must learn this. Okay, you have to learn these elements. So components, okay, some of the common components whatever are there in the textbook, those you have to learn. Okay, so those points we'll discuss. So electrical elements are common components. First one is cell. This is the cell, positive terminal, negative terminal, positive terminal, negative terminal. Second one is battery. This is a battery, so I am taking this a battery. This is a battery, positive terminal, negative terminal. Next one is switch. This is switch, open switch. So if dot is not there, that is open switch. If dot is there, that is closed switch. So this is the open switch. And coming to the closed switch, so this is the closed switch. And coming to the fifth one, so that is resistor. Resistor is a device which is used to resistor is a device which is used to oppose electric current. Resistor is a device which is used to oppose electric current. Resistance is a phenomenon of opposing the electric current. Resistor is a device which is used to oppose electric current. Resistance is the phenomenon of opposing the electric current. Okay, so now you can see this is a rheostat, this is a rheostat, or this one, or we can take like this also, understood? Rheostat. Resistor is a device which is used to oppose electric current. Rheostat is the device which is used to regulate the regulate the current without changing the voltage source. And coming to the ammeter, this ammeter, positive terminal, negative terminal. Coming to the eighth one, voltmeter. This is a voltmeter, positive terminal, negative terminal. Coming to the ninth one, so ammeter, voltmeter. Next one, wire joining. So this is a wire joining. And the next one, 10th one is wire crossing. This is a wire crossing. And the 11th one is bulb. So this is the bulb symbol. Okay, bulb symbol. So here this is the cell, battery, open switch, closed switch, resistor, rheostat, ammeter, voltmeter, wire joining, wire crossing, and electrical bulb. These are the commonly used components in the electric circuit. So now we will discuss about now, so electric circuit, electric circuit, electric circuit, electric circuit. So here, very important point is they will ask about open circuit and closed circuit. So what is open circuit? If switch is not closed, so switch is open, that is open circuit. If switch is closed, that is closed circuit. So open circuit and closed circuit. So they will ask about these 2 points. And coming to the next one, here I am taking the bulb. This is the bulb and ammeter. This is the ammeter. And next one is battery. So this is the battery. Next one is switch. Okay, so here I am taking current is passing here. So here you can observe, oh, sorry, bulb is, this is the bulb. Na, 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 na. So here first one is conventional current, conventional current, conventional current, conventional current, and second one is electric current. Second one is electric current, electric current. Okay. So what is conventional current and what is electric current? Conventional current is nothing but the flow of positive charges. Positive charges are moving from positive terminal to negative terminal. So the flow of positive charges is known as conventional current. Sir, why you are calling it is conventional current and electric current? So why you are calling these 2 types of current? So only one current is there. So but actually before finding electron, proton and neutron, all these elements, so before that, okay, so elementary charges, before that they already given the statement that is the flow of positive charges. The flow of positive charges direction is considered as the electric current. Okay, so instead of changing all those experiments, all those there, all those of their hard work and everything, instead of changing those things, better we can consider this same definition. So that is the reason we are considering it is a conventional current. And coming to electric current, after knowing the movement of electron gives the electric current, the movement of electrons gives the electric current. So electrons moves from negative terminal to positive terminal. Electron moves from negative terminal to positive terminal, whereas positive charges are moving from positive terminal to negative terminal. Okay, electron is moving from negative terminal to positive terminal. So that is nothing but conventional current is nothing but positive charges. So movement of positive charges. So positive charges are moving from high potential to low potential, whereas electrons are moving from low potential to high potential. Low potential to high potential. So there is one question regarding this one. Sir, will electron flows from high potential to low potential or low potential to high potential? Electron always moves from low potential to high potential. Okay, so that is about electric current and conventional current. And coming to the electric circuit. So what is electric circuit? Electric circuit is nothing but, so a closed and continuous path of an electric current is known as an electric circuit. So inside of this circuit, circuit, it is a closed path, right? So it is a closed path and continuous path of an electric current. So a closed and continuous path of an electric current is known as an electric circuit. Okay, so that is about electric circuit and conventional current and electric current. So now we will discuss about electrical potential and potential difference. Electrical potential and potential difference. Okay. So later, based on that one, problems also they will ask regarding the electrical potential and potential difference. Even heating effect of electric current also we will use those terms. Okay. Electric potential difference. First one is potential difference. Potential difference. What is the potential difference? Potential difference is nothing but work done to bring unit positive charge. Work done to bring unit positive charge. So I am taking this the conductor. This is a conductor. So I am taking this the point. So this is the point A and this one is the point B. So we are this is the positive charge. So we are doing work. We are doing some work to bring unit positive charge. We are doing some work to bring unit positive charge from one point to another point within the conductor. So V equal to W by Q. V equal to W by Q. So SI unit of potential difference is volt. SI unit of work is joule. SI unit of charge is coulomb. SI unit of charge is coulomb. 1 volt is defined as 1 joule of work is done to bring 1 coulomb of charge. 1 volt is defined as 1 joule of work is done to bring 1 coulomb of charge from one point to another point. Okay, within the conductor. Understood or not? That is the potential difference. So, electrical potential. Coming to electrical potential. Coming to electrical potential. Electrical potential is nothing but work done to bring unit positive charge from infinity to the required field. So I am taking this thing. So this is the point. I am considering positive charges at infinity. This is the required field. So we are doing some work. To bring unit positive charge from infinity to the required field. From infinity to the required field is called electrical potential. So V equal to W by Q. 1 volt is defined as 1 joule of work is done to bring 1 coulomb of charge from one point to another point within the conductor is called potential difference. Electrical potential is nothing but work done to bring unit positive charge from infinity to the required field. Okay, I hope it is very clear. Next one. Now we will discuss about Ohm's law. So we will discuss about Ohm's law. So let's start Ohm's law. Ohm's law. So the potential difference across the ends of the given metallic conductor, is directly proportional to current flowing through it. V is directly proportional to I. V equal to IR. Okay, at constant temperature. At constant temperature is very, very important. And materials required. What are the materials required? Materials required. Point number one. First one is 4 cells of 1.5 volts of each. Okay, and coming to the second one, nichrome wire. Nichrome wire is an alloy of nichrome wire. So nichrome wire is 0.5 meter length. Nichrome wire is 0.5 meter length. And coming to the ammeter, and coming to the fourth one is voltmeter, and coming to the fifth one is switch, and coming to the seventh one is sixth Sixth one. So sixth one. So sixth one is connecting wires. Okay, connecting wires. Okay, so now, so circuit diagram. This is a circuit diagram. Circuit diagram. Circuit diagram. Okay. Circuit diagram. So how many cells are required? 4 cells. Each potential is 1.5 volts. So each potential is 1.5 volts. So I am taking here 1, 2, 3, 4. So I am taking 4 cells. And ammeter, this ammeter. And the next one is resistor, this a resistor. Next one switch. Okay, so across this one I am connecting voltmeter. So current is passing here. So current is passing like this. Circuit diagram. So next one, procedure. Procedure is first connect one cell. And note down the reading of ammeter and voltmeter, and connect two cells. And note down the reading of ammeter and voltmeter. So repeat the process for 3 and 4. So here you can observe, first you have to connect one cell. And note down the reading of ammeter and voltmeter. Ammeter reading is current, voltmeter reading is potential difference. And after that you have to connect to two cells. And again in the again you have to note down the reading of ammeter and voltmeter and repeat the process for 3 and 4. So you have to repeat the process for 3 and 4. So you have to connect 3 cells and note down the reading of ammeter and voltmeter and repeat the process for so fourth cell also. Observe the reading of ammeter and voltmeter, and you have to tabulate all the values. So you have to tabulate here. I am drawing the tabular column. So over here you can see the first one is serial number of cells, ammeter reading, voltmeter reading, V by I value. And here you can observe, so I am taking this serial number and the number of cells and the current potential difference V by I equal to R. So serial, how many cells we have to take? We have to do experiments for 4 cells. So 4 columns you have to mention here, 1, 2, 3, 4, and the number of cells 1, 2, 3, 4. Here number of cells, serial number, ammeter reading is current, voltmeter reading is potential difference, V by I equal to R. From this Ohm's law, so we can take R equal to V by I. So that is nothing but resistance. Ohm's law gives the definition of resistance. definition of resistance. So V equal to IR, V equal to IR, R equal to V by. Understood or not? So that you have to take. So after mentioning all the values in the tabular column, so we have to draw the graph for V and I. If you draw the graph for V and I, the graph is straight line. Okay, so linear. So I am taking V on y axis, I on x axis. The graph is straight line. Okay, starting from origin. Sir, why it is straight line? Why it is starting from origin? Because we are starting with one cell, right? So before connecting first cell, ammeter reading, voltmeter reading, both are at 0 degrees. Both are at 0. Both are at 0 reading. Okay, so I can say 0 reading. Then once you connect one cell, once you connect in the circuit one cell, then automatically the reading is start showing in ammeter and voltmeter. Is it correct? So after connecting first cell, the readings of ammeter and voltmeter start showing. Okay, start showing. So it starts from rest only, right? It starts from 0 reading only, right? That's why. So the graph is starting from origin. The graph is starting from origin. That too linear. So why it is linear? Because so when current is increasing, automatically potential difference increases. If potential difference increases, automatically current is increasing. Why? It is directly proportional. V is directly proportional type. Okay, at a constant temperature, the potential difference across the ends of the given metallic conductor is directly proportional to current flowing through it. V is directly proportional to V equal to IR. Okay, that is Ohm's law. And from that, so R equal to V by. So Ohm's law gives the definition of resistance. Resistance is nothing but phenomena of opposing the electric current in the circuit. Okay, so resistance. Resistor is a device which is used to oppose the electric current in the circuit. And the SI unit of resistance is ohm. Okay, so here I connected here. Okay, yeah, so exam, all the best, do rock. Okay, so always believe yourself, be confident, so do your best. Definitely, I hope you all do well. Okay, so I'm hoping all the best for everyone. A big big all the best. Okay, so tomorrow is our exam, science exam, so do rock. So definitely you will. Okay, so ante తగ్గేదేలా ఓకేనా సో అంతే ఇంకా so come to the point now. So V on y axis, I on x axis. Okay, now you can take so the potential difference. So V on y axis, I on x axis. The graph is curve. The graph is curve. The graph is curve. The graph is curve. Okay. So if it is straight line starting from origin. Okay. So this is for ohmic conductor. Sir, what do you mean by ohmic conductor? The conductors which obey Ohm's law, those are called ohmic conductor. The conductors which obey Ohm's law, those are called ohmic conductors. The conductors which does not obey Ohm's law, those are called non-ohmic conductors. Okay. So the graph is very, very important. Circuit diagram. Sometimes they will ask. So the graph, VI graph is straight line. Okay. So how you will get this graph and draw the circuit diagram to obtain this graph. Draw the circuit diagram to obtain this graph. So they are asking circuit diagram. So they are asking this one. Okay. So they will give this one. Okay. So VI graph is straight line starting from origin. How it will be obtained? Okay. And then one more thing, draw the circuit diagram to obtain this graph. So you have to draw this circuit diagram. Sometimes they will ask for 2 marks. And the definition of Ohm's law, 1 mark. And the related problems, compulsory problems they will ask. And so I mentioned like resistance of the bulb, resistance of the conductor. So related to that questions also they will ask. Okay, so I hope it is very clear. And coming to the so maximum these points only. Graph is very important. Definition is very important. Circuit diagram is very important. And so remember these points also. And we are connecting step by step. That is very, very important. Step by step, one by one you are connecting. You are not connecting at a time all the cells. Understood? Keep in mind when assistant reasoning type question comes, logical question comes, MCQs type of question comes. So you are connecting cells one by one to experiment the Ohm's law. To experiment the Ohm's law, how you are connecting one by one. So that's why you are drawing with the dotted lines. You are drawing with the dotted line. That is the reason you are connecting one by one. Understood? So that is very very important. And the next one we will do one more, that is resistance. Factor depends on resistance. That is also very very important. Activity is very important. Okay, once again check that activity. Okay, so first we will take a normal wire, so nichrome wire. After that, double of its length. After that, so area of the cross section is increases. After the, instead of taking nichrome wire, you are taking another wire, like that. Different materials. Okay, different materials you have to take and do experiment. Factor depends on resistance, also very important. So once check that experiment. And coming to the next one, resistance and resistivity. Resistance and resistivity. So now we will see. So these differences are what I'm going to explain. So the difference between resistance and resistivity. So definitely problem can be expected based on this concept. One problem can be expected, and MCQ's point of view very important. Assessment reasoning type very important. So like a resistance increases, so resistance depends on temperature. Resistivity depends on temperature or not. Okay, if temperature increases, resistance increases. So like that type of questions they will ask, and this all the points. So we'll discuss now. We will discuss now. Check here. So resistance and resistivity. So R is directly proportional to L. R is inversely proportional to area of the cross section. So R is directly proportional to length of the conductor. R is inversely proportional to area of the cross section. R is directly proportional to L by A. R equal to rho into L by A. So this is very very important. Okay, so resistance depends on temperature, and coming to the resistance also depends on nature of the material. Nature of the material. So very very important. So make sure that you are learning all these points. And coming to the resistivity are normally you have to take R equal to rho into L by A, rho equal to RA by L, rho equal to RA by L. So here SI unit is very important for so they will ask in the exam for 2 marks. SI unit. Okay, so very very important point. So make sure that you are learning these points. 3 marks question. So this they will ask for 1 mark. 1 mark, and this relation also 1 mark. And this difference, so it depends on the factors. So 1 mark. So temperature, resistance depends on temperature. Resistance depends on nature of the material. And here, so this is here we can expect for 2 marks. That is SI unit of resistivity, ohm meter square by meter. So meter get cancelled. Ohm meter is the SI unit. Okay, so compulsory you have to remember. So for MCQ's point of view, at the same time MCQ's point of view and derivation, sometimes they will ask directly for 2 marks also. Okay, directly for 2 marks also this question they will ask. That is a derive the SI unit of resistivity. Derive the SI unit of resistivity. So you can write from here, no problem. R is directly proportional to R, R is inversely proportional to 1 by A. So like this, R equal to rho into L by A. Rho is the proportionality constant. Rho equal to RA by L. SI unit of resistance is ohm. SI unit of area is meter square. SI unit of length is meter. Meter get cancelled. Rho equal to ohm meter. Ohm meter. Very very important. So this is for 2 marks. Okay, this is for 2 marks. And especially, so in this, so whatever I have written on the board, based on that one, so many questions can come. Many. Problem wise, problems, theory, okay, differences and units, nature of the material, okay. So many questions, and one more thing, one more question also they can ask. Okay, so resistivity depends on physical dimensions. No, resistivity does not depend on physical dimensions. Resistivity depends on temperature and nature of the material. Okay, resistivity depends on temperature and nature of the material. It does not depend on physical dimensions. So it's very, very important. So make sure that you are following all these points. I hope it is very clear. So this is about resistance and resistivity. Resistance and resistivity. So after that, we will discuss about resistors are connected in series combination. So many questions they can ask. So difference is 3 marks. So length, area. So whether it is depending on length and area or not. So temperature, material. Individually they can ask. Individually they can ask. So sir, out of give allotted marks they won't ask no more. So even though but so maybe the allotted marks for the chapter, that marks will be allotted based on this question. Maybe it depends. So questions comes from this concept. Then what we have to do? So we have to prepare everything. We have to be ready for the okay. So in all directions. So you have to be ready. Okay, so that's why I'm telling. Keep focusing, keep practice, keep listening, keep revising. Revising the concepts, revising the concepts. Okay, na? So that is only one point. Revision, revision, revision. Number of times I have to revise. So next one, now we will discuss about resistors are connected in series combination. So derivation can be expected. Okay, so we can't neglect each and every point, especially from electricity. Okay, so electric current. So we can't neglect any point. That much importance you have to give. You have to provide particular time for this chapter because that much important it is. Okay, even one or two questions comes also. That too, if you known question, maybe remaining chapters maybe somewhere twisted questions from the chapter, maybe it will be easy. So there are chances, right? There are chances. So whatever you are preparing, so read each and every point, be thorough with each and every concept. Okay, so definitely you can do better in your exams. Okay, so definitely you'll do rocking. Resistors are connected in series combination. Resistors are connected. Resistors are connected in series combination. Series combination, very simple series combination. And here, so circuit based problem will come. Even theory, like theory questions also will come directly. They will ask for MCQs also. So one I am taking resistor, 3 resistors. Sir, why you are taking only 3 resistors every time? So you can take any resistors, no problem. So according to the textbook we are considering, you can take 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. That is your choice. But exam paper won't be sufficient to draw that many resistors. So better we go for 3 resistors. Understood or not? So draw 3 resistors only. So here current is passing, yes or no? If you connect circuit, automatic current will pass. This is R1, R2 and R3. So across R1 I am connecting V1, across R2 I am connecting V2, across R3 I am connecting V3, across R3 I am connecting V3. Okay, so positive terminal, current is passing, so throughout the circuit current is same. Yes or no? Throughout the circuit current is same. Maybe potential difference is different because so different resistors. So potential current is same. That is IP IS equal to I1 equal to I2 equal to I3 equal to I. Understood or not? So from Ohm's law, V equal to IR. V equal to IR. Okay, so V equal to IR. Now, so from Ohm's law, V equal to IR, right? So IS equal to I1 plus I2 plus equal. Now potential difference we are taking Vs equal to V1 plus V2 plus V3. So that's enough. IRS equal to IR1 plus IR2 plus IR3. So shall I take I common? So if you are taking I common, then I am taking I common. R1 plus R2 plus R3. So I get cancelled. So what is the remaining? So RS equal to RS equal to R1 plus R2 plus R3. R3, R2. So if number of resistors are connected in series combination, if a number of resistors are connected in series combination, what happens? So RS equal to NR. So if a number of resistors are connected in series combination, RS equal to NR. Understood or not? And one more question here. So which physical quantity is constant in series combination? Which physical quantity is constant in series combination? Can anyone say which physical quantity is constant in series combination? Okay. So physical quantity, which physical quantity is constant in series combination? So that is, yes, current. So the physical quantity which is constant in a series combination is current. Current is the physical quantity. Oh. Current is the physical quantity which is constant. Okay. Oh, oh my God. Okay, done. So I hope it is very clear, right? So now I will get cancelled. RS equal to R1 plus R2 plus R3. RS equal to NR. I hope it is very clear. Next one. Now resistors are connected in parallel combination. Resistors are connected in parallel combination. Parallel combination. Parallel combination. Parallel combination. Parallel combination. You parallel combination. Dun, 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 dun. So now resistors are connected in parallel. Sir, how can you identify resistors are connected in parallel and resistors are connected in series combination? So if you connect, so one end to another, another end to another, so like that, if you connect, if the current is same throughout the circuit, then we can say, so resistors are connected in series combination. Now, resistors are connected in parallel combination. One, two, next one, three. Okay, so here I'm connecting. This is R1, R2 and R3. Here I'm taking ammeter. So I'm taking this. Positive terminal, negative terminal current is flowing. Okay. through R1, I1, through R2, I3, through R3, I3. So here potential difference is same. So Vp equal to V1 equal to V2 equal to V3 equal to V. Understood or not? Potential difference is same. But from Ohm's law, V equal to IR, right? I equal to V by R, right? I equal to V by R. So current is different, right? Current is different. So IP equal to I1 plus I2 plus I3. So that is nothing but V by RP equal to V by R1 plus V by R2 plus V by R3. So I am taking V common. If you take V common, then the remaining values are, so V by RP equal to V I am taking common 1 by R1 plus 1 by R2 plus 1 by R3. So V will get cancelled. So the remaining values are 1 by RP equal to 1 by R1 plus 1 by R2 plus 1 by R3. I hope it is very clear. Understood? If n number of resistors are connected in parallel combination, that is 1 by Rp equal to, so n by R, Rp equal to R by N. So that formula is very important. Based on that one, so problems also they will give. So based on that one, they will ask problems. So make sure that you are practicing all the points. So which physical quantity is constant in parallel combination? Potential difference. So here potential difference, the potential difference is the physical quantity which is constant in parallel combination. Understood or not? So I hope it is very clear. So next one we will discuss about heating effect of electric current or Joule's law of heating. Heating effect of electric current or Joule's law of heating we will discuss. So now now you can see, so V equal to W by Q. From this one, W equal to VQ. Yes or no? V equal to W by Q, W equal to VQ. Power equal to rate of doing work. P equal to electrical power. Electrical power equal to rate of doing work. That is nothing but VQ by 2. So rate of flow of charge is called electric current. Rate of flow of charge is called electric current. I equal to Q by T. So P equal to V into Q by T is what? So Q by T is VI. So we know electrical energy is given P into T, that is VI into T. So we know V equal to IR. V equal to IR, you have to substitute in the place of V. Then you will get, so H, heat produced in the conductor is directly proportional to square of current. So H equal to I square RT. H equal to I square RT. Heat produced in the conductor is directly proportional to square of current. Heat produced in the conductor is directly proportional to resistance. Heat produced in the conductor is directly proportional to time. So I hope it is very clear. So this is very important derivation, and at the same time, so each and every line is a formula. So based on that one, they will take any formula and give problem. So based on this one, they may give problem. Based on this one also they will give problem. This one, anything, any line. So among these formulas, so any one formula they can take and give problem. Okay, so that much important it is. So each and every line is very important. Each and every line gives one problem, so one statement. Understood? So that's enough. So based on this one, we'll do problems. Short circuit is nothing but the direct contact of live wire and neutral wire takes place. Then heavy amount of current will be drawn from the mains. Then overloading is nothing but high voltage appliances on at a time. Then heavy amount of current will be drawn from the mains. Understood or not? So short circuit is nothing but the direct contact of live wire and neutral wire takes place. Then heavy amount of current will be drawn from the mains. Then overloading means high voltage appliances on at a time. Then it may lead to the short circuit, maybe insulation of the wires may turn. Then so direct contact of live wire and neutral wire takes place, and heavy amount of current will be drawn from the mains. So like due to this reason, so fire will occur in the building. Okay, fire may use, like this all things will happen. Okay, so based on this one we'll do problems based on electric current. So we'll do problem. Let's start doing problems. Okay, let's solving. Just 1 minute, so we'll start to. Ready? Are you all ready for doing problems? A copper wire, a copper wire of resistivity so cross-sectional area of 20 into 10 power minus 4 centimeter square. Calculate the length of this wire. Calculate the length of this wire. Okay. So here calculate the length of the wire required to make a 10 ohm coil. 10 ohm coil. Okay, so after doing few problems, So I'll start magnetic effects of electric current. Okay, so just try to do the problem. So what is the answer for this question? So answer to this question is, so let me know. So I'll start once again at 8 o'clock. So after taking small break. Okay. So Okay, so the answer is 125 meters. So we have to substitute the values. Okay, we have to check what exactly they given the data. So I have to identify the given data. So 125 meter is correct answer. 125 meter. So let's solve. Let's solve the problem. Solve the problem. Let's solve the problem. Na, na, ni, na, na, ni, na. Na, ni, na, ni, na, na. So your resistivity is given. Resistivity is the ohm meter. Resistivity equal to 1.6 into 10 power minus 8 ohm meter. And the cross sectional area is given, that is A. So A equal to 20 into 10 power minus 4 centimeter square, and resistance is given R. So R equal to 10 ohm. Understood or not? But here you have to understand one thing, that is they given centimeters. So area of the cross section is given centimeters. So 1 meter equal to 100 centimeter. 100 centimeter. 1 meter equal to 10 square centimeter. 1 centimeter equal to 10 power minus 2 whole square meter square. So 1 centimeter square equal to 10 power minus 4 meter square. So 1 centimeter square equal to 10 power minus 2, okay, 10 power minus 4 meter square. So then area equal to 20 into 10 power minus 4 into 10 power minus 4 meter square. Then so they are asking to find out length. We have to find out length. R equal to rho into L by A. So L equal to RA by rho. Then you can take L equal to how much R? 10. So your area of the cross section is 20 into 10 power minus 8. Resistivity equal to 1.6 into 10 power minus 8. You'll get cancelled. So if you solve it, you'll get 125 meter. Understood or not? This is the answer. So we'll go to the magnetic effects of electric current, so that I will explain. Okay, so I'll explain that chapter. So thank you so much for joining and attending. So do like, share and subscribe to Student Brain. Thank you so much.